So today in class, we looked through the properties of the types of parallelograms, and we saw how all of the parallelogram properties apply to the other kinds of parallelograms, rectangles, rhombuses, and squares. And now we are going to look at the non-parallelograms, which are the kite, we're going to draw in a trapezoid, and the isosceles trapezoids. So for a kite, looking at our properties, the thing that we are given about a kite from the definition is related to the sides. For a kite, and you can really see it in a visual of a kite, you have two pairs of congruent sides, but it's not the opposite sides that are congruent here. It is the consecutive, the sides that are next to each other. So we will say that the consecutive side pairs are congruent. And that's what you know about the sides of a kite. They are not parallel to each other, but we do have two different pairs of sides that are congruent to each other. For the angles, there's not a lot of properties that we have about the angles. However, when we look at these, we are able to prove that one of the pairs of opposite angles are congruent. So we're going to eventually draw in both diagonals. So let's go ahead and draw in the diagonal between the intersection points of where the two congruent sides meet. Thinking about this, I could quickly prove these triangles congruent. If I think about reflexive property, these two triangles are congruent to each other, and that makes this angle congruent to this angle. So we have one pair of opposite angles that are congruent. One pair of opposite angles that are congruent. The other pair are not congruent, and as you look at the diagram, they really don't look like they're the same size, and that is true to scale as we're looking through these problems. Okay, so that's the angles, that is the sides. The big additional thing is going to come when we look at the diagonals. Okay, so I'm going to go ahead and draw in the second diagonal. And before I get too deep into that second diagonal, I want to go back to the fact of the two half triangles that we proved congruent to each other. Well, thinking about CPCTC, what that also tells us is that also would allow us to say that this angle and this angle are congruent, as well as this angle on the bottom and this angle down here. So we can say here that one diagonal bisects the opposite angles. It's the non-congruent angles are the ones that end up being bisected. So that diagonal bisects as we go. Okay, now look at those diagonals drawn to scale. Wow, do they look perpendicular? And that is going to be true. The diagonals are perpendicular. And that is what we know here. The diagonals are perpendicular. Now, this is actually a setup for our perpendicular bisector theorem. Remember the two-point equidistance theorem. Both these points, because of these congruent segment pairs, are equidistant to the endpoint. So not only are those diagonals perpendicular, but the other diagonal, the one diagonal going, in this case, vertically, bisects the segment. So we can say that the one diagonal bisects the other. So one diagonal is the perpendicular bisector of each other. So three properties. One of the diagonals bisects the opposite angle. That diagonal is also the perpendicular bisector of the other diagonal. So they are perpendicular. One of them is cut into two congruent pieces, and we have some angles that are congruent. Alrighty, let's move on to the trapezoid. So I intentionally did not draw one in here so that we could draw ourselves a trapezoid. I want you to draw non-isosceles. So I'm going to draw two pairs of parallel sides and then two sides that look like they are different lengths to each other. Okay. Alrighty, we don't have a ton of properties, so this is going to go pretty quick. The sides. In this case, we have exactly one pair of parallel sides. We have exactly one pair of parallel sides. For angles, taking a look here, the opposite angles are definitely not congruent to each other, so we cannot say that. But what we do have is that the same side angles are going to be supplementary. So if I go 1, 2, 3, and 4, 1 and 2 are supplementary. Actually, let me say same side interior. This is along the parallel lines. So 1 and 2 are supplementary, as well as 3 and 4. As for the diagonals, sadly, we have no special properties. They are not congruent to each other. They do not bisect each other. They do not bisect any angles. There is nothing that is special when it comes to the diagonals of a trapezoid. Okay. However, when it comes to an isosceles trapezoid, we do have a couple of properties. So, as we go from here, these sides, we have one pair of parallel sides. Those are what we're going to call the bases. So the parallel sides are the upper base, and then the lower side we'll call the lower base. Then we have one pair of congruent sides. Like an isosceles triangle, we're going to call those the legs. So we'll say the legs are congruent. Okay, for the angles, now looking at this, the two angles at the top appear to be the same size, and so do the angles at the bottom. We're going to call those upper and lower base angles. So the upper base angles are congruent, and the lower base angles are congruent. And then same as above, the same side interior angles are still going to be supplementary. So an upper base angle and a lower base angle, those will be supplementary to each other. Okay, last final property of all of our types of quadrilaterals is that when we draw on the diagonals of a trapezoid, they are going to be the same length. So when we look here, those do look like they're the same length, and that is true. So diagonals are congruent. So it's going to be very important for class tomorrow that you come prepared by having all of these properties down. You're welcome to look through and think about any ways that we are able to prove these different properties throughout these different shapes, why this has to be true. It's very interesting to kind of look through and think about, but these are all of your properties, and then tomorrow we're going to dive into how do we use these in problems and in application settings.